Assalamu alaikum wa rahmatullahi wa barakatuh. Very good morning to everyone. As introduced, today we are going to continue our journey on the produced and industrial water. Specific attention for the first session will be on the operational excellence and also cost optimization. It's a continuation of what have been discussed yesterday. Yesterday we had a very good insight, very good topics around produced industrial water across water management, from strategies, regulations, into innovative solutions and AI. Today the journey will continue. We'll focus more today, inshallah, on efficiencies, reducing the cost across all the value chain of the water management operations that will directly contribute to the sustainability. And that's mainly the main thing that the developers and the companies and the operators, they look forward to reduce the cost, be more sustainable on the water management. So without further say on this, join me please to welcome the first presenter, Sulaiman Rawahi. Sulaiman is an energy efficiency engineer. He works in OQ Alternative Energy. The topic will be doubling energy efficiency in high water cut wells, a competitive decarbonization pathway by debottlenecking the service production network, and it is a field case study. So, Sulaiman, please join me. Sulaiman Rawahi is an energy efficiency engineer with OQ Alternative Energy, part of the Energy Excellence Group. He holds a bachelor's degree on petroleum and natural gas engineering from SQU. Sulaiman has utilized simulation tools and new technologies to implement sustainable solutions, focusing on reducing carbon emissions, contributing to the company's net zero goals. Sulaiman, floor is yours.
Assalamu alaikum. Thank you for these opportunities. So our discussion today, which is about doubling energy efficiency through a digital twin for the high water producer wells. So first, we'll start by introducing OQ and our challenges in our upstream with the water production in high water cut wells, and using the digital twin and simulation model to debottlenecking surface network and end up with the result and conclusion. So OQ operates in 17 different countries, working across full energy value chains. So it is a global company that provides energy services and solutions for different assets and clients, covering both upstream, midstream, and downstream. So it helps other assets in their decarbonization journey, and it's actively seeking for growth and innovation, and it has set a sustainable target. It's aimed to reduce their emissions by 25% of their emissions coming from Scope 1 and Scope 2 by 2030, and achieving the net zero carbon emissions by 2050. So for that, it set new rules for the new investment to support the decarbonization journey. OQ Alternative Energy is the national champion for renewable energy in Oman. It supports another assets and to reduce their carbon emissions and to shift it to more cleaner and renewable energy sources. And today we are from Energy Excellence Department, which is the central department within OQ Alternative Energy. In this department, we are leading the projects which contribute to reduce the carbon emissions, as well as reducing the operation cost. Energy Excellence Department is the first pillar need to take in consideration due to the highly impact within low capex solutions, and highly value in terms of energy intensity, decarbonization, and sustainable solutions. OQ Alternative Energy supports Oman to be the leader of the hydrogen energy by making the hydrogen as a major part of the economy by 2040 and achieving the net zero carbon emissions by 2050. So today, our focus today in OQ upstream challenges with high water production in high water cut wells. Actually, around 30 to 40% of our energy consumption and carbon emissions coming from the producer water wells. And here we have a simple schematic of our OQ upstream facility. We have the high water cut wells, we have the station facility, end up with the water disposal wells. So high water cuts, that means there is a huge amount of water coming with the oil production, which have a lot of challenges in our upstream facility. Starting with the station facility, so high water production, that means there is a high water treatment cost, and it will make some limitation in the station. So the station cannot handle that much of the hydrocarbon due to the high water limit to be treated from the producer wells. Also, high water production, that means will require high energy consumption for the water disposal pumps, and this huge amount of water will create some resistance in the water network and creating some back pressure. So that's back pressure means we need more energy to pump that water through the pipes toward the water disposal system. And here we have a simple production profile. We can clearly see this a huge amount of water compared with small amount of oil coming from the production wells. This, of course, will create some cost for the treatment, and as well as it will create some back pressure. And here in the left-hand side, in the right-hand side, we have benchmarked the back pressure range. So we consider any well that operate with a back pressure more than 435 psi gig is considered a high back pressure producer wells. And we can clearly see that most of the wells are operated with a high back pressure. So that back pressure will create a lot of challenges in terms of energy consumption as well as carbon emissions. And we have categorized the back pressure levels starting from 435 psi gig to 801 psi gig. So we are trying to solve this back pressure wells for every ring, moving from higher one to the lower one, and etc. Here, our decarbonization roadmap, we have some projects that we are working on it in the upstream, starting with the ESP back pressure optimization. We are using some simulations tool to identify the back pressure areas in the upstream, and we try to run some scenarios to solve this back pressure area. And also we are working And also we are working within the ESP pumps itself. We are working on that motor, shifting the induction motor to the permanent magnetic motor for more efficiency and less consumption, as well as we are implementing some projects like a hybrid power for the ESP artificial lift between the solar and diesel, and also are using some diesel management software to manage the diesel consumption in the upstream facility for each equipment, and end up with the off-grades using the solar battery for the ESP as a hybrid energy source. And our focus today with the first one, which is the ESP back pressure optimization. Digital twin and simulation model. Actually, we are using a simulations tool to optimize and simulate our surface network to identify the back pressure areas in the field and trying to solve it, starting with the non-CAPEX solutions by running several scenarios in this simulation tool and managing the production between the high and low water cut wells. We are trying to reduce the flow with several percent from the high water cuts and replace this decrease with less water cut wells. End up with by looping the line between the header and sub-headers in the high back pressure areas and high production. This is a simple schematic of the surface network. It consists of the wells and MSVs and headers, end up with the inlet manifold as well as the water disposal wells. we can clearly see this is a surface network, so it needs to build this surface network, it needs to be integrated with the concept department as well as the subsurface department. We are gathering the BNIDs of our facility from the concept department, and we input the subsurface data like the pressure and flow parameters. And here we can clearly see that the impact of reduce the water production from the producer wells in terms of the high in the back pressure as well as the energy consumption. Here in the first group of wells, this is high water cut wells. So we are trying to reduce the flow around 10 to 15% of these wells, and we replace that reduction of the flow by increasing the flow of less water cut wells, and we end up our optimization by a reduction in total back pressure and energy consumption. So we are trying to manage the flow, reduce the water production without impact the net oil from the producer wells. And here, so we are trying to reduce the water from the total gross production without impacting the net oil, and we end up with some result with CO2 emission reduction around 46,000 tons CO2 per year, and which equivalent around 10.7 thousand gasoline powered by single vehicle taken off the road, and energy intensity reduced by 1 kilowatt hour per POE, and cost saving around $1.9 to $2.6 million per year. So the idea here, there is a non-capex solution in our industries that we can utilize it and generate some saving in terms of energy intensity and carbon emissions. So this is our conclusion that say, so reduced water production will have a lot of impacts in terms of energy consumption and carbon emissions in our facility. And now we are targeting the high back pressure areas. So after we confirm the result with the upstream, we will expand our project to cover another areas within our upstream facility. And we explore all options, including the no and low capex solution with minor adjustment for the fast-track decarbonization, and the project to be extended to the review of capex solution for adding pipelines, further debottlenecking the network. This is my presentation, and thank you.
Thank you so much, Suleiman. Very good insights around the challenges on the water cut wells. And I hope one day the collaboration between all the operators in Oman to also work on the ESG and the target of the strategies around net zero strategies for Oman. Thank you for the insights. So our next presenter is Saeed Al-Anqoudi. Please join me to welcome Saeed. Saeed will present the evaluation of biological media filled back bed columns performance in treating polluted water. A bit introduction about Saeed. Saeed is a proactive health, safety, and environment inspector. He is currently pursuing a bachelor degree. Saeed brings hands experience in safety compliance, regulatory adherence, risk management, and he is dedicating to promoting safe and sustainable practices. Saeed, the floor is yours.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم والصلاة والسلام على محمد وعلى آله وصحبه أجمعين. أما بعد أحييكم بتحية الإسلام. السلام عليكم ورحمة الله تعالى وبركاته. My name is Saeed Al-Anqoudi. I'm an HSC inspector working in the oil and gas industry, currently pursuing my bachelor's degree with UCLAN at the International College of Engineering and Management, اللي موجودة في شارع المطارات, if you guys know it. Before you go inside, you will see 2 fire trucks, and once you go inside, you will see a big plane, beside it, a helicopter. Also, you will see firefighters conducting emergency drills, probably twice a week. You will see big guys like me wearing overalls, conducting HSE inspections, and doing walkthroughs as well. And you will find well engineers. My recent research focuses on using natural resources in Oman as a filtration system. Now, in today's session, I will be discussing the evaluation of packed bed columns' performance in treating polluted water. Inshallah, we'll go for a quick ride through these 8 agendas. تلوث المياه ما يخطر ببالك أو ما تعرفوا عنه. ولا تحاتي راح أجيك وين ما تكون وأعطيك الميكروفون. It's an engaging. Anyone knows about water contamination? In any language. You can speak English, Spanish, Mandarin. You say it. Your good name and a quick introduction about yourself, and you can go ahead.
Thank you. I am Ayoub Al-Kindi from Magis Industrial Services. So water contaminant is the pure water who's get contaminated by any other media like chemicals, oils, turbidity, whatever. So that will call water contaminants.
Thank you. Anyone has a different view? Yes, tell.
Assalamu alaikum. My name is Basim Shabaka from Marafak. Water contamination, it is a change in the chemical and the biological composition of the pure water and non-compliance with the standard of drinking water like WHO and Oman standard number 8, 2012. Any change, any deviation from the chemical and the biological composition is considering as a contamination and should be treated. Thank you.
Jazakallah khair. Anyone else has a different view, idea? The floor is yours. نكمل بعض هني ترى. أيوة. You want to participate? All right. Water contamination is a significant issue characterized by the presence of harmful dissolved chemicals. I think from the answers given, we all agree that these contaminants pose serious risks to both environmental and public health. Now, effective solutions for treating polluted water are essential to ensure safe usage, including drinking water, which is critical for sustainability and environmental preservation, especially in the Middle East. Correct me if I'm wrong. Anyone? This study aims to assess the effectiveness of a biological media-filled packed bed columns in performance in treating polluted water. The focus is on utilizing natural resources in Oman, specifically natural silica sand and coal-based granular carbon. By optimizing the packed bed columns performance, or the packed bed column design, the goal is to achieve effective water treatment. Now, we face a significant challenge related to water scarcity and contamination. The increasing demand of clean water and the limited availability of freshwater resources make it crucial to develop efficient water treatment. This study aligns with Oman's vision, which emphasizes sustainable water resources management. Now, for the filtration system design for this study includes 2 main components, as I mentioned before, natural silica sand and coal-based granular carbon derived from Omani trees. The objective is to assess the performance of these materials in removing contaminants from water both sand and the coal are evaluated for their effectiveness in filtration. And as shown in the table, our findings indicate that both of them are effective filtration material. Now, the best treatment were observed at a 15 centimeter height. The experimental setup involved testing various columns heights. I started with 5 centimeter, moving to 10, and ending up with 15, where I had 0 absorption. Now, as shown in the screen, we conducted laboratory experiments to measure the concentration of contaminants before and after. In our laboratory setup, I used precise measures, techniques to ensure accurate results, to monitor the performance of natural silica sand and coal-based granular carbon. To measure the concentration of contaminants before and after treatment, this allowed for precise monitoring and evaluation of filtration effectiveness. Now, the key findings of this study show that both of them are can effectively remove contaminants from water, while natural silica sand had a higher absorption, making it slightly more efficient than the coal. Now, both materials showed 0 contaminants detected at a column height of 15 centimeter, as shown in the graph. The natural sand silica can be practically applied in various water treatment systems. Their effectiveness in removing contaminants makes them suitable for different scales of water treatment applications using locally sourced materials. What I used, I took 2 samples of sand, one from UT and one from Barka. Now, as for the coal, I took the coal derived from Omani trees. I only used 1 sample. Walillah alhamd, it went well. Now, using locally sourced materials like natural silica sand or the sand and the coal has several benefits. It reduces the reliance on chemical treatments and minimizes environmental impacts and supports sustainable practices in water management. Now, in conclusion, both of them are effective in removing contaminants from water. The optimal configuration for the backbed column height is 15 centimeter, as shown in the screen. As for the future research, should focus on investigating new combination filtration media to enhance the performance. Additionally, testing under real-world conditions will provide more insights into the practical applications of these materials. Integrating natural silica sand and coal-based granular carbon water treatment systems supports sustainable water management in Oman. Aligning with Oman's Vision 2040, my name is Saeed Al-Anqoudi, وهذا كان وقتي معاكم وشكرا جزيلا.
Thank you very much, Saeed. Very good insights on the water management and the contaminations, water contamination in general. A very interesting subject, especially we understand that the research and development is really very critical and crucial for the operations. And it makes sense that we need to really focus and invest more on these technologies, on these ideas, to minimize the contaminations. Thank you again. Our next presenter is Engineer Samia Shukeli. She is a concept process engineer in PDO. Samia going to present a subject related to turning a water handling challenge into a valuable opportunities at PDO. Samia is currently working as a concept process engineer in PDO, supporting operations in troubleshooting activities and also well delivery activities, providing in-house coaching and also base of design development for the projects. Samia has a total of 10 years of diverse experience in oil and gas. She worked as a process engineer in detail design engineering, concept engineering. Samia, floor is yours.
Assalamu alaikum. This presentation is related to turning an opportunity, turning a water handling challenge into a valuable opportunity at one of BDO fields. So this presentation will cover the challenge background and the opportunity drivers, objectives, what is the specification of the produced water, and what are the concepts to identify to resolve this issue, and what is the selected option and what is the scope for that selected option, along with the process description on how to resolve this issue. So starting with the challenge background, first of all, the produced water management within the cluster is a closed system where the produced water is used for water injection through water injection wells, and around 45% of the produced water is used for the water injection, and minor volumes of the produced water is used for rig and hoist consumption based on the demand on that. Around 10% of the produced water we are using for the rig and hoist as per requirement, and the remaining produced water is used or it is disposed through deep water disposal wells. However, as per the latest forecast, it shows that there is a constraint in produced water disposal system, which cause a deferment or oil deferment of more than 300 meter cube per day, and this is mainly due to the requirement to close some of the wells to meet or to limit the produced water to the limitation of the deep water to the produced water disposal system. So based on this challenge, these are the opportunity drivers to minimize the deferment by eliminating the current constraint in the disposal system, and also to reduce the OPEX and CAPEX, which is associated with operating of the water disposal system, and also to meet the corporate commitment of GHG emissions, as well as improving energy efficiency. The opportunity objective is to eliminate the current produced water disposal constraint by finding another sustainable long-term solution, and this is through service handling facility. So we are replacing the deep water disposal wells by having or by constructing an evaporation ponds where the salt will be formed from these evaporation ponds or from the produced water through a salt crystallization environmental process where the water will be evaporated and we'll end up with having the salt. This objective is in line with the corporate objective of having sustainable water management, as deep water disposal wells are not considered that. And also it is in line with having zero deep water disposal wells within BDO by 2030. Currently BDO is importing salt for the drilling activities, and now by having this facility, once this project is on stream and once we are having these evaporation points where we will be producing salt from it, then this will cover the need or the demand of BDO for the salt, and there will be no need to import the salt for such drilling activities. So these are the specifications of the produced water. We are having oil and water. It is around 25 to 69 ppm, TSS 2 to 12, TDS 148, around 148.5, and the salinity level of the produced water is 147.8, and the expected produced water from these evaporation points is minimum 97%. So at the initial stage of the project, once the problem or the constraint is defined, at identify phase, certain or different concepts were proposed, and it has been evaluated in terms of their technical visibility as well as their economics. And the main two options or the main two concepts were identified at that stage to resolve the produced water constraint where the do nothing and continue with deep water disposal wells by drilling more deep water disposal wells to cater for the additional produced water, or by stimulating of the existing deep water disposal wells. And the second concept was the service handling. So if we are looking to the first option, which is do nothing and continue with deep water disposal wells, few challenges were there with these options, like there were no plan to drill additional deep water disposal wells within the cluster beyond 2024, and this is in line with the corporate strategy of having zero deep water disposal wells by 2030. So this was not an option. Also, another challenge is the challenge related, or the issue related to operating the deep water disposal wells, as if we want to increase the efficiency of these deep water disposal wells, we need to do frequent stimulating, which is a costly operation, and which is increasing the OPEX side of the disposal system operation. And also the third challenge was, if we continue to drill more deep water disposal wells with ESPs, then with time, these wells will have their own issues in terms of injectivity, and which will cause water breakthrough to the existing producer wells. And so this option was not supported, and it was not selected due to the high OPEX, high CAPEX also as well. For deep water disposal wells, we need to consume more power, which is impacting the GHG emissions for sure. So for the second concept was the service handling. For the service handlings, we're having two options. One option is to have to produce salt from the produced water through the evaporation ponds, and the second option was to extract minerals from the produced water. And however, between these two options, we went to the service handling by having evaporation pond to make the salt, because due to the quantities of water as well as the quality of this water, mainly the salinity level of the water, and also because we need this salt for the drilling activities for BDO demand. And from the economic point of view, when we are comparing this option, having a salt-making facility, comparing with do nothing or drilling a new deep water disposal wells, this option it is showing that it is very attractive option compared to deep water disposal well, and hence we have selected this concept to resolve the issue, and based on that, a project form with following scope. We are having mainly two scope. One is the pipeline scope, and the other scope, which is the salt-making facility. This is an overall schematic of the system. We are having the existing system where we are having the produced water, and we are taking a tie-in from the produced water system manifold or header, and from there we are installing a new pipeline, and from this new pipeline we are transferring the water to the salt-making facility. The salt-making facility, it is basically different type of ponds or a series of evaporation ponds, and we are evaporating water, and then from this water we are reaching to the salt, which will be harvested, and then it will be transferred or transported to local refineries, where it will be further processed, and then to meet the specification of the drilling salt used in BDO. And this is a simple description of how the salt will be produced. First, the produced water will be supplied by the new installed pipeline in the system, part of this project, and then it will enter the intake ponds, where the dispersed oil will be extracted, or it will be skimmed or removed, and this skimmed oil will be transferred back to the facility through vacuum tankers. And then the water will continue, and it will be further processed in a series of evaporation ponds, where the water will be evaporated. It will be evaporated, and it will be evaporated till we reach the required salt-saturated densities. and then it will be further processed again in in the crystallization pounds, where the harvestable floor of salt will be formed. And the last step will be the transportation of the salt to the local refineries. And this is, here you can see, this is a simple schematic that we are having the incoming flow. It will enter through the intake, it will come into the intake water pounds, and then we are skimming the oil. The oil, and from there it will pass through different two series of evaporation pounds, crystallization pounds, and then we are having the harvestable salt. Regarding the executing strategy of this project, it is an EPC project where engineering, procurement, and construction, it will be done through interbidding among the service contractors, and also the operation of this facility will be done by a third party. This is the final slide where it shows the project schedule. The select phase of this project has been completed and done last year, Q3. And the FID is approved for this project. Currently, project is in the define phase and FEED stage, and the expected on-stream date for this project in 2027, Q3. Thank you.
Thank you so much, Samia Shkelia, for the interesting subject. It's very important to really utilize the produced water in any other forms or means that will drive more energy efficiency and sustainable water management. And I hope by 27 you will, inshallah, get this successful project. Is a story that you will inshallah present it in the events, coming events, inshallah, in 2027. Thank you for that. Our last but not least for this morning session, the operational excellence and cost optimization, presenter Mohammed Al-Blushi. Mohammed is a senior process engineer from Majis Industrial Services. The topic will be on the management of operation challenges in seawater intake. Mohammed Al-Blushi is a senior process engineer specializing in water treatment and distribution with over, mashallah, 18 years of experience. He has expertise in plant operation, GIS mapping, asset management, and process optimizations. Mohammed holds an MBA and degree of mechanical engineering. Mohammed.
Assalamu alaikum and good morning. Today I'm going to talk about operational challenge in seawater intake. First of all, we'll start we are going to talk about introduction of the seawater intake. Then we'll start talking about screening and chlorination plan. And then we'll talk about our challenge in seawater intake. And then we'll conclude, inshallah. First of all, for my introduction, always I like to introduce in the picture. As you see, this is the overview of our seawater intake. We have two types of the seawater intake. I mean, we have one seawater intake, but two planned in one, two phase in one plan, phase 1 and phase 2, as it's showing in the picture. I have to be clear in the picture. Also, if you see, we have breaking water. In between two breaking water, we have oil boom. And outside also we have online monitoring buoy. And also nearby outfall, we have another online buoy. In two phase in seawater intake, phase 1 and phase 2, the capacity of the phase 1 around 350,000 cubic meter per hour, and phase 2 around 400,000 cubic meter per hour. And for each phase, we have separate electronation plan. Phase 1, we have separate electronation plan, and phase 2, we have separate electronation plan. Also, we have separate screening water, bar and band screen in phase 1, and bar and band in phase 2. For the screening, we have total screen in the seawater intake around 21 bar and band screen. And also, as I say, we have electronation plan for the 8 generator in phase 1 to produce sodium hypochlorite 700 kg per hour, and phase 2 around 625 kg per hour. And in between, we have pumps and pipe to dosing in distribution bay and 4 bay. The difference between screen, bar screen and band screen, if you see in the picture, the band screen, we have a mesh in the band screen. The capacity of the mesh, 3 mm. And bar screen, that it work, the capacity filtration, it will work with the 30 mm. What does it mean? I mean, anything or any particles from the band screen, any particle, it will not move the band screen if it is more than 3 mm. Like fish, particles, anything. It will not pass to the band screen, from the band screen, if it is more than 3 mm. So our screening capacity, 3 mm in the seawater intake. And as mentioned, we have 10 bar screen and 10 band screen in SWIP 1, and phase 2 also we have 11 bar screen and 11 band screen in SWIP 2. This is also, as mentioned, for the electronation plan. This is a diagram. We are taking water from the bar and band screen by the pump to the filters. Then, as per the chemical reaction, we are injecting DC current, high DC current to the generator to produce sodium hypochlorite. So we are producing sodium hypochlorite and H2, it means hydrogen. And the sodium hypochlorite will be stored in the tank and dosing by the pump to the distribution bay and 4 bay. We have agreed with all customers inside Sohar port to dose FRC in our distribution bay from 0.4 to 0.8 ppm. And our major customer in Sohar port, all generation power like Al-Batana, Sohar Aluminium, and SPC, and our major company or customer also OQ, all OQ refinery. We have methanol, Shadid, many company it is in the Sohar port. They are using seawater. So here we'll start with our challenge. From the picture, it is in 2020, we received huge quantity of tiny fish attacked. So that one of the environmental challenge, we call it environmental challenge, because in environmental challenge, we select, in my presentation today, I take only few of the subject like tiny fish and jellyfish. Also, I will talk from the environmental, I will talk about algae and red tide. There is many challenges also, but for the time we'll talk only for the three types of the environmental challenge. Also, we have other challenge like oil spillage and drinking activity, and other challenge also we have as like asset challenge. We have also an asset challenge and cost and budgeting challenge for the operation. Okay, in this picture, if you see, in 2020, we received huge quantity of the tiny fish. So that quantity of the of the tiny fish, if it is passed to the customer, it could be damage our customer facility. To mitigate our system and customer system, we are doing many things like continuous physical inspection for the screen to identify any damage in the band screen, and operating screen continuously to remove the preventive screen damage and monitoring differential level. Also, we are dosing continuous sodium hypochlorite. Also from the environmental change, we have jellyfish attacks. This happened in the picture. This happened, I think, in 2018. We received huge of the jellyfish inside our seawater intake, and that to mitigate our system. For the jellyfish, we have special equipment like we are using. It is called using mag tube. That mag tube, all the jellyfish, it will go to the screening or band screen, and the band screen to remove all the jellyfish from the screening or distribution bay. It will go to the bit. We are taking all the jellyfish from the bit and sucking all the jellyfish to the mag tube. What's the benefit for the mag tube? To suck all the jellyfish and to avoid any return back again to the sea. And we are monitoring same activity, dosing more chlorine and continuous physical inspection, and operating our screen also with the divers to check all the screen from inside the forebay on distribution bay. Other challenge also environmental, we have algae bloom and red tide. During last 2 months, we are receiving also too much of the algae. That algae, sure, it will damage our customer system if it is received there. And our band screen will be in place to remove the algae, and we are dosing sodium hypochlorite. In addition here, we have 2 online monitoring buoy. That online monitoring buoy, it will be measure the chlorophyll and other parameter to check the water quality. For the other challenge, we are receiving oil spillage. In event of any spillage nearby our seawater intake, sure that oil, if it is passed to the customer, it will damage customer facility. So to prevent our customer and our intake from the oil, we have boom barrier. We call it boom barrier to stop the oil in our entry of the seawater intake. So also for that, we have emergency response with the SIPC and Oman BISCO to skim all oil from our seawater intake. For the other challenge, also we have dredging activities. During the expansion of the port, some company, they are doing dredging nearby our intake. So that dredging, it will change the turbidity and SDI. Sure, it will impact to our customer. So our customer, they will impact it with the turbidity and SDI as like silt and debris. So our band screen, it will be in place to remove all the silt and debris. And we are doing also same activity like dosing more chlorine. We are doing inspection for the bar and band screen. As well, we are communicating with our customer to protect their system. Also, in addition here, if we are seeing or observing abnormal quality or increasing the quality of the turbidity or SDI, direct we have to communicate with the dredging contractor to stop or reduce of the dredging. Other challenge here like asset management. As you are aware, our seawater intake direct connecting with the seawater intake, with the seawater, and seawater, it is very salty, and corrosion and marine growth, biofouling, it will be there. To protect our system and customers' system also, we have computerized maintenance management. It's called CMMS to reduce for regular maintenance. And we have a redundancy system for all the equipment and pumps, screens. Also, we are carrying out the anti-corrosive paint to extend life of the equipment. And we have all the equipment connected with a system called, it is called cathodic protection system to protect our system from the corrosion. We have special diving also for inspection and cleaning. And as well, we are doing every overhauling. Operation cost and budgeting. We are optimizing operational cost and energy by using best practice in operation. For example, all the pumps, it's connecting with a variable frequency drive to save energy. And we are conducting life cycle assessment for all assets. And using, we are upgradation of the environmental, all assets to Luster technology to improve the performance and saving energy. In conclusion, seawater intake system facing multiple challenges, like environmental and other challenge, what we have it and what we talked about. But by smart design and regular maintenance, real-time monitoring and environmental complaints, we are ensuring the reliability and efficiency and sustainability of the seawater intake. Customer satisfaction is very important for us, and always we keep them happy. Thank you.
Thank you so much, Mohammed, for the valuable insight, great efforts as well on managing the seawater intake challenges. The seawater intake challenges nowadays is a big challenge, not only in Oman, but also in the GCC. And we hope one day that there are lots of innovative solutions, investment in technologies to really help all the operators, because the consequences is not only on directly on the operation efficiency, but also a shutdown of 1 hour refinery cause 100 millions, losses. So there's lots of financial losses as well in this aspect. For the potable water, it's worse. Because once these attacks of all the seawater intake issues like algae, jellyfish, and red tides, the RO plant will definitely be down. And I think that the great efforts made by all the operators, not only in Oman, is beyond as well to minimize the impact on this. But we would like to see more investment on this regards. Our session is almost over. Now we are into the Q&A session. I would request all the presenters to please join me here on the stage. We will open the questions to all the presenters. Feel free to. So I hope someone is managing the microphones for the audience as well, please.
Thank you very much for this session, very incentive session. So my question to Engineer Mohammed Al-Belushi for water intake. So after most of this water intake, if I understand, for cooling and other process. So when you discharge back this water to the marine, are you meeting 159 marine MD? And which technology you are using to meet such requirement? Thank you.
Thank you for this question, and very important question. For Majis, we are supplying our all customer or major customer screening seawater. So our water, it is same seawater, but it's screened with the capacity of 3 mm. And the customer, most of the customer, like what's a company that what they are generating, power generation, they are using for cooling purpose. So the reject water to the canal, it will be same, with the same components of the water, the same analysis of the water. And some other company, they are using for producing water, to generate the water, potable water and processed water. And that water, it will be as per the regulation of the environment unit. They have special SOP, and water should be tested by the environmental unit. It should be as per the condition and rule. There is rule. If they did not reject the water as per the rule, they have regulation with the environment unit. And all canals, it is monitoring by our SIPC. They are monitoring and checking the parameter of the water. Thank you. I hope to answer your question. Yes, for the water which going to the inside the process, they are rejecting water. They call it, or we call it, effluent water. That effluent water, they are rejected to our network. We are taking again. We are supplying them processed water, and we are taking as a effluent water. We have a special plant we call CTRB, effluent treatment plant. We are treated that plant again to the processed water. And we are supplying them again as a processed water.
I have a question. Assalamu alaikum. Engineer Said Al-Anqudi, thanks for the presentation to all presenters. Interesting, you say you can treat the contamination of water, but you didn't mention what kind of contaminants. So contaminants depends on the industry. Yeah? So what are you targeting to treat exactly? What contaminants?
Thank you for giving this question, first of all. I used methylene blue as a contaminant in treating the polluted water. And I used a spectrometer to measure the concentration before and after the treating. So methylene blue was the contaminant. And what I used is only on a laboratory in college, not in real life. But for future research, inshallah, we'll go for it. My plan is to test groundwater as well, and rainwater, stormwater, and we'll go from there.
And the water that you have used, it's not the water not samples from the industry, it's samples, the tap water, no more, and you have added the contaminants.
Yeah, the distilled water I used. And I started from there. Hope I answered your question.
Shukran.
Jazakallah khair.
شكرا طلال العولقي. Thank you very much for the excellent presentations. I have several questions. My question to Engineer Sami Shkeli. I think it's very interesting to see the commitment of BDO to have a zero disposals by 2030, and the shifting to mineral extractions of that salt. And regarding if you can shed more light about the economics, usually when we think about the disposing, it's a very, coming from upstream point of view, it's a very attractive for them to find alternative way to have a mineral extractions and to secure an off-takers. So my question, how's the economics between the disposing versus mineral extractions, at least for every barrels of water or every meter cube of water? This is the one. The second one regarding the salt extraction or mineral extraction. I understand there is salt extraction, but in your analysis, did you think more about some of that critical mineral extraction, which is, I know there is some lithium availabilities on that waters that used to be disposed. Those are my questions. Thank you very much.
Thank you. Regarding the mineral extraction and the salt extraction, at the initial stage, we have checked both options in terms of their visibility, but as I said that we went to the salt making facility due to the high salinity of water and also the quantity of water. However, for the mineral extraction, we are having other projects which are covering this aspect of extracting minerals. But as per our project, we didn't went that deep into the economic evaluation of the minerals compared to the deep water disposal wells. We did this economic evaluation between the salt making capex or cost compared to the deep water disposal in terms of the OPEX cost, the capex cost of ordering these wells, as well in terms of the power consumption, because huge power consumption is associated with operating these. So in terms of the economic evaluation, we have that comparison, and based on that, the MPV of this project has shown that it is very attractive, taken into consideration that we'll be using that salt and there will be no need to import and pay for the salt again. So hope this answering your question.
Any more question? Side, please.
As a follow-up question to Samia, because it really is an interesting project. Hopefully we can see it in reality soon, and a good strategy for BDO to focus in salt making from this disposal. Actually, what is your measure to make sure the quality of quality of the salt not contaminated by hydrocarbons? What is your measure to make sure that the de-oiling process is efficient? Because if salt contaminated with hydrocarbon at the end, maybe you cannot sell it. So have you considered this in your study or expectation?
In the select phase, we have already contacted few specialized vendors who are specialized with the salt making facility or the evaporation ponds, and they have provided us with their concept reports with all specifications and what are the process and how they can achieve the 97%. And they have already in their concept, they have already provide us with that we are able to meet 97 as minimum. And further to that, we are processing. Once we are harvesting the salt, we are further processing the salt in local refineries to ensure that we are meeting the specification of the drilling before we are using NBDO operation. So we are having that guarantee by also ensuring that we are processing in the local refineries.
Any more questions? In the middle, لو سمحت.
Assalamu alaikum. Morning. My question is to Engineer Mohammed Al-Balushi. So with regard to the seawater intake quality, I saw it interest the issue with tiny fish as well as jellyfish. Yeah, so what other technologies have you explored? Have you explored things like bubble curtains at the pepper pot intake, and what has been the outcome of that study in terms of mitigating or avoiding altogether the ingress of sea life like tiny fish or jellyfish?
Yeah, thank you for this question. Actually, our design, it's designed for such as like this environmental. But during of that, if we receive heavy or heavy quantity, that much of the quantity, it will affect to our screen. And as you saw, sometimes we are receiving also like vapors, like other particles, that we are challenging our operation. But at the same time, as I told you, we have special equipment like now we are using mag tube, and we have also injecting continue dosing and check dosing in both intake, that helping us to monitor this challenge.
Sorry, just a follow-up question to that. So with regard to rejection, once you've rejected the jellyfish and tiny fish, for example, how do you manage that waste?
We have special contract with the municipality and BIA contract. They have their own SOP to monitor this jellyfish and other particles. We are supplying this to the municipality and BIA company.
Right. Okay, got it. Thank you.
Yeah.
Thank you. Sorry for Said, during your filter, how much the settlement time for the water to go past this filter? Or are you using the normal pressure, or you have to pressurize this water to go through this filter? Thank you.
Thank you for your question. Well, as for the timing, what I used exactly is I used the packed bed column. It's going to be a 15 centimeter height. So I added the sand or the coal, and after adding it, I will pour the contaminant water, and then I will just measure it by a timer. So there's no pressure, no nothing. Yeah, due to gravity. It's going to filter itself, and it showed 0 contaminant, and I measured it by using a spectrometer. Yes.
Maybe another last question before we wrap up. Okay, so thank you so much. I would like to thank Saeed, Suleiman, Mohammed, and Sami as well for their good insight, valuable information and case studies. I would like to thank you all for your active participations. It was an interesting subject, interesting topics as well on the operational excellence and cost optimization. Thank you so much.
Thank you, and please, Engineer Saeed, as a thank you for all the presenters, he will be handing over certificates of appreciation. First, we're starting with Sulaiman Al-Rawahi. Saeed Al-Anqudi. Sami Al-Shukeli. and Mohammed Al-Balushi. Please, all speakers together for a group photo. Thank you all. And now for the coffee break. Next session after break starts at 11. Please be back at the hall at 11. Thank you so much.
ببند هذه الأموين بندون هو بندهن لا
Hi everyone, please be seated because we're about to start the second session for the day today and last session, I promise. We're gonna finish early today as well. Thank you all for coming, and now it's session 5, Sustainable Reuse of Threatened Effluent and Produced Water, chaired by Professor Salim Zikri, Professor, Department of Natural Resource Economics, College of Agriculture and Marine Science, Sultan Qaboos University. Doctor, please welcome to the stage.
Thank you very much. Good morning, everybody. Assalamu alaikum wa rahmatullahi wa barakatuh. So we're going to start our session number 5, essentially about industrial water treatment and reuse. Our first speaker is Mr. John Linden. Where is Mr. John? Okay. So let me introduce John. John is gonna talk about anything to energy, wastewater, remediation, and pushing the boundaries of what's possible. John is co-founder and CEO of X2A and Utopia Mother X. He has a long-standing background within oil and gas and sustainable industries, having previously founded SEM Aberdeen. He has amassed a wealth of knowledge about waste remediation and advanced projects to a more sustainable level. He now manages a portfolio of green projects ranging from biofuels to wastewater remediation, and he is actively pursuing the next advancements which can be made in water security for all. Through the Sayata project, he now has his sights set on completely utilizing all of the produced water from the oil industry and transforming it to irrigation grade, which will then be put to use throughout Oman by means of farming and other uses. John, the floor is yours. You have 15 minutes, please. Thank you.
Good morning, everybody. Thank you very much for the chance to present today. So X2E, effectively, what we look to do is make sure that we utilize absolutely everything. And one of those precursors that we want to make sure that we preserve in the best possible way is water. You know, we see water as the most valuable resource in any industry that we're involved in. Now we're involved in Wakud, the biofuel, biodiesel industry. We're involved in SAF development. We're also involved in biogas development as well. Each and every single one of those is a natural resource. It's an organic-based feedstock. And with organics, as you can imagine, in a country like Oman, where you have a lot of desert and not a lot of area to grow natural organics, what we want to do is we want to change the way the terminologies of wastewater and disposal of water in one of the most stressed countries in terms of water in the world. Currently, Oman, around about 85% of its freshwater systems come from groundwater resources. So where you see the efflage systems, the natural watercourse lines, that is what we see is a detrimental decline from the seawater intakes that we have in Oman. There's an endangerment of the pool of groundwater resources and groundwater to lower what we would call the header pressure from seawater intakes. So effectively, if you imagine one of your bottles of water, that pressure, if you poked a hole in the bottom, would allow that fresh water to come out. As that goes down, if you imagine that seawater was trying to push against that hole, what stops that hole from taking the intake of seawater. So as you lower the header pressure and you lower those reserves, that pressure becomes less and less and less. So the force of seawater and seawater intakes becomes more prevalent, and you end up flushing out and you end up killing your freshwater reserves. It's exactly what happened in Saudi. They went heavy in agriculture, pooled all their freshwater reserves, and then all of a sudden you find hypersaline intakes all the way through there. And that's exactly, from that process, is that you're taking away your head of pressure from your freshwater reserves. So when we look at this and some of the discussions that we've had through the week, especially in terms of algae and microorganisms coming to the freshwater systems, coming into the seawater intake lines, this is it's a trigger for us to see exactly some of the major issues, not just within Oman, but within the GCC region. But Oman has a lot of focus, and it's about to have a lot more focus. I don't know if you saw in The Observer this week that there was an article on a specific type of algae, which looks like it twinkles. So Oman can be seen from space, and its ocean looks like it's sparkling. That is a nice thing to see, but it's also a trigger for us, for any environmentalist, to see that there's some inherent issues that are coming towards the infrastructure and the ecostructure of what we have in Oman. And part and parcel of that is wastewater runoff. The algae blooms, especially, that we see here, you see it massively in the US, where you have organic runoff, you have organic loading runoffs that go into the ocean, that feeds the algae, and then you have high temperature, and then you also have hypersaline. So with all of the brine, the heavy brines, the seawater disposals, the hyperbrine disposals, produced water disposal lines going back into the ocean, it creates this trigger point of all of the perfect conditions for algae to bloom and to explode, as we're seeing more and more prevalent as we go through the years. And it really is, that algae formation that is a foresight that we want to see. And a part of that is also the depleting oxygen, which becomes part and parcel of the coverage of the algae. We've got the vast amounts of sunshine here that should oxygenate the water. Now, unfortunately, when you have an algae cover, the sunlight can't go through the blanket of algae, it can't reoxygenate the water, and it can't actually absorb and kill the very thing that's supposed to be there. So oxygen depletion is a big key componentry there. And then having the hypersaline discharges, so the more that we have RO, the more we have forward osmosis, reverse osmosis, and we're pumping that saline, hypersaline residues back into the ocean, the hypersaline basis there is another kicker and another trigger for us to see the amplified effects of what we have from the disasters that are coming our way. So Oman is, unfortunately, renowned to have the largest dead ocean in the planet. And what you see within the graph there is basically monitors around algae formations in the ocean itself. And as you can see, it's heavily along the coastlines of where we have heavy petrochem discharge, not so much agriculture. As you go up in Karachi into Iran, that is nutrient loading discharge from a heavy agricultural basis. But because there is no real tidal stream within the northern Gulf, what that acts as is a deterrent from being able to wash these hypersaline brines and push them round to be discharged and to be moved into other oceanic areas. So there's two problems that found within that side. So how do we deter? How do we change this? And this is what some of our fellow speakers are going to be talking about today, is the solutions of taking away one problem area to allow us to let the ocean itself recharge, let it heal, and actually come back to its natural equilibrium. The unfortunate line of what we're about to see is a cataclysmic event, that if we continue to push the ocean limits, its nutrient limits, and see the organic loadings further within the ocean on one of the currents, the mid-Atlantic currents that you typically see that carry temperature ranges, that change temperature ranges through the ocean, may carry this hypersaline event into Asia. And then we're going to see even further issues as it just explodes into a heavy event. So within X2E, within our subcos, within what we're doing right now, that's exactly what we're looking to do, is to take the issues of how do we recharge these systems, how do we take produced water, how do we take wastewater, and how do we put it back into the systems, back to recharge the clean water systems so that we can ensure that what we need in terms of agriculture, Oman has stated, and within our work especially, to grow feedstock for biogas, feedstock for oil crops, feedstock for SAF development, methanol production. We want to make sure that we have the lowest carbon intensity score-based feedstocks there. And with that increase, it's about 300% increase in agriculture. You're going to need 300% increase in water management and water usage. So where's that going to come from? We need to recharge and redevelop. We need to redefine how we describe wastewater. We need to redefine how we use the terminology around disposal wells and disposal evaporation ponds. The air doesn't need the water, the ground does. So we need to effectively look at the lowest carbon intensity score-based programs within water development that we can do, alleviating that water stress, enhancing the resilience of the nation and its number one resource. I always typically joke that Oman doesn't produce oil, it produces water. 11 to 1 barrels of water to a barrel of oil. It's a heavy, heavy water cut basis. So we need to utilize that in the best way that we possibly can do. And then what that does is it activates another GDP increase for agriculture, agricultural practices. And then from that, it gives us feedstock resilience to go and grow our own feedstocks to supply these additional industries that we can put to good use, increasing ICV content for Omanis and new jobs. Thank you very much.
Thank you very much, John, for this short presentation, instructive. We're going to move to the second presentation today from Ms. Musa Al-Ruqaishi. Ms. Musa is going to talk about from waste to gain. Ms. Musa Al-Ruqaishi, a production chemist at Petroleum Development Oman, with over 4 years of experience in the oil and gas industry. Her expertise primarily focuses on heavy crude production in the south of Oman, and she holds a bachelor's degree in chemistry from Sultan Qaboos University. Ms. Musa, to the floor, please.
Assalamu alaikum wa rahmatullah. Thank you for introducing me here. Today I'm going to present this title, which is From Waste to Gain, Maximizing Returns by Improving the Water Quality System in one of PDO fields we have in south of Oman, using chemical application there. Okay, through my presentation, I'll take you through the problem statement to describe the main challenge we are facing there, the process overview as a schematic for the facility and what type of oil and water processing we have there, the methods that we have tried and tested, including the laboratory tests and field trials as well. Then we'll take you through the results of and the outcomes of the trials and laboratory testing and the benefit statement, and finally just to kind of appreciation for all team involved there. Starting with the problem statement, like 4 years back, we faced a challenge in one of the processing facility we have. It's a main oil gathering facility. The main challenge we faced was in the water quality there. Because we couldn't manage to meet the water quality specification of oil and water of 50 ppm in one of the big capacity tank. It was brought as a new technology to cover the high demand of water processing in that such facility. But unfortunately, as per the design, this technology should work without any chemical solution there. But somehow we face a challenge to meet the design specification for the outlet water quality. And this bring more challenges downstream of the water system there, including the injectivity issues downstream, as this water finally will be re-injected again to the reservoir to maintain the reservoir pressure, as well as damaging some of the water treatment plant we have there, including some reed beds and crops. So it also affects that side. As we can see here in the trend, it's showing high oil and water content. It reached almost 500 plus ppm, and the design specification should be less than 50 ppm. You can see here how the water sample looks dirty with a lot and significant oil content there. Here is the mainly overall the process overview of the main station that include this tank. We have very high level. We have free water knockout tank, dehydration tank by gravity, just to have two-phase separation, oil and water. And then the water will be further processed downstream in GFT tanks, some also CPI, TPI technologies. And then this water will be re-injected again to the reservoir, and some of them will be used for watering that crops that I have mentioned before. For the oil side, for the water side downstream, there is also another further processing, and that loosed oil will be reclaimed again and recovered and repumped again to the same station. Here in the methodology side, so after we faced this challenge around 4 years back, we thought why not to try some chemical solutions there to enhance the water quality. So we brought an idea to have demulsifier and de-oiler, two chemicals, to help, maybe it might help to overcome this challenge in this tank. We did some bottle testing in the lab to see the efficiency of these chemicals. We selected some multiple products, and as you can see in the pictures, some of them are showing some, more efficiency comparing to the other. And then when we landed up into one product, we do like different concentration. We prepare different concentration of that chemical to see what is the optimum dose rate that can work for the challenge we are having there. Then after that, we decided, as the laboratory test gave good results, we decided to move to a field trial, because as you know that the conditions on site there, the tank condition, ambient temperature also can affect the performance of these chemicals. We have started a field trial. As you can see here, moving from left to right, we have started injecting the chemical into inlet to this tank. You can see the improvement in the clarity of water sample after 5 days and then after 1 month. And currently the water sample looks like the last water picture there. So we managed, alhamdulillah, after the field trial to achieve the good water quality that we need. And you can see here in the trend, it was showing to the left the oil and water trend, which was hitting more than 500 ppm. And after we introduced demulsifier and de-oiler to the chemical, we managed to reduce the oil and water all the way to around 50 to 70 ppm oil and water. And alhamdulillah, we managed also to sustain such performance and help the tank specification to be met. As a benefit statement, it's not only water quality enhancement, but it also covers too many things related to HSC, because for the HSC part, let me go through them one by one. Here we have the HSC. For the HSC, the recovered oil that we normally bring it back again to the station, there are trucks transporting this oil again to the main station, and also there is direct lines as well. So for the trucks transportation, we observed that there were a huge reduction in the number of trucks transporting oil back to the station, from 12 trucks per day to almost 2 trucks only per day, which was a great achievement there. Also, in terms of kilometer driven and transportation, it's been observed that we managed to reduce the kilometer driven from 175,000 to 29,000 only per year. And that also cover other aspects like the manpower exposure, transportation risks, and all other field transportation related risks. In the process safety aspect, recovering this oil from an open pit will definitely bring some oil ingress, air ingress, bringing more oxygen to the system, which is really a critical aspect that can cause some integrity issues and challenges later on. And because of that, we kept some oxygen scavenger skids ready that we need to use and inject oxygen scavenger to scavenge the dissolved oxygen in the system to avoid any integrity issues that might happen. But this one currently is stopped. For the GHG, due to the reduction in transportation and other power facilities, the estimated calculated GHG reduction is expected to be more than 200 tons of CO2 annually. Here is the truck monthly reduction, as you can see. It was fluctuating. This is 1 year trend. It shows the reduction and the effect of reducing the number of trucks transporting this oil back to the main gathering station. And here finally, I would like to appreciate all the teams which was involved. It wasn't only a production chemistry department effort. It was an integrated effort, mainly by operation. They supported as well from their side a lot. They were trying also to look for some solutions from the operational side, playing in the level, tank conditions to enhance the water quality as well. Corrosion team as well was involved. The contractors, the chemical vendors to evaluate the chemical performance using lab tests. And third-party operation as well was working with us, and I would like really to appreciate all the team involved. Not sure if some of them are presenting here with us today. I mentioned the last point, the way for expensive with high consumption. We are injecting almost 1,000 liters per day of these both two chemicals.
Research scientists until 2002 focusing on the development and application of complex engineering challenges. Please welcome Dr. Gessler. So you have 50.
For those that aren't familiar with it, it's a physics-based produced water or F-based. Produced water or effluent, of course, is contaminated in air process piping, and so that'll be the third example that we'll look at, and those with CFD. How do you go from a laboratory scale with CFD? How do you go from a laboratory scale to full scale where you're treating large quantities of water? So we need to basins, we want to achieve mixing efficiency as quickly as possible, and then we want to achieve hydraulic efficiency as well. So common issues in produced water treatment engineering, this is what we hear from people that we work with. pilot testing versus the full scale, and it usually almost always comes down to a scale-up problem. It worked really good during the pilot scale, it worked good on the benchtop, but then when they did it in the real world, for some reason it doesn't work, and it's hard to understand why. You know, the concentrations are the same, they're adding the same amount of chemical in a relative sense, but for some reason it's not scaling up. So this is typical of what we see. You know, in the lab, you might get go from left to right. You're going to go from dirty water to clean water when you add the chemicals, but then in the real world, it just doesn't quite work. So the bottle testing shows great results, but we can't duplicate it in the field. And you'll see here in a moment why that can happen. And these are problems that end up being really well suited to address with CFD. So that's where the CFD comes in. It's not chemistry, it's the scale-up portion and the mixing portion. So another typical comment that we get has to do with unexpected chemical dosage, because when the chemical engineers or the chemists tell us how much of a certain chemical we're going to need, that's really the minimum amount, because they're assuming that you get perfect mixing or that you achieve an optimum solution. And in reality, if you can't achieve that level of mixing, then you're going to need more chemicals, because you have to design to the worst mixed spot, not the best mixed. And then the other part that comes in there similarly is aeration. We have the same problem. You can aerate it, but if it's not well aerated everywhere, then again you have a mixing problem that CFD can address. The third case that we're going to look at has to do with a complex piping issue. So you end up moving large quantities of water. You can have unbalanced flow. You can have pumps that shut down or unexpectedly, and those will cause pressure transients in the pipelines, and those pressure transients can result in overstressing of pipes. They can result in pump cavitation, water hammer, and ultimately cracked or failed manifolds. So that picture is actually from the example that we're going to look at, where we'll see a pressure transient that was caused by the way the pumping system was designed. So 3 case studies. We're going to look at an above ground storage tank mixing problem. We're going to look at an aeration issue in an above ground storage tank. Then we're going to look at a piping failure due to a pressure transient. So this is the above ground storage tank mixing issue. And what we see here is we have a, let's see if I have some animation here, or an arrow that's going to come in. There we go, that's what I was looking for. So water comes in at the bottom of the tank there, and then it goes out to the right side. And as the water goes across the tank, let's see if my laser pointer works, the water goes across and it circles back, and you end up with these 2 dead spots here where there is very little mixing. And so if you want to achieve a certain water quality, now your dosage has to be designed around those dead spots, right? So you're not getting good mixing inside that tank. And we want to come up with a solution to improve this. And I guess one way that we could do is just put a big paddle mixer in the middle of the tank and mix it mechanically, but that's energy intensive and not terribly clever. So maybe there's a better way to do this. So we're going to go ahead and model that. So we want to get rid of the bad mixing, get rid of the dead zones and the overspending on chemicals. So let's take a look here at the first alternative. We're going to go from 1 inlet to 2 inlets. So now we have an inlet at the top and an inlet at the bottom. We're going to split the flow evenly between those 2. And we'll go ahead and take the water out on the side like we always have been. And then we're going to go ahead and simulate this to see what happens. So it's even split of the flows. The flow crashes into each other, and what you end up with is an inherently unstable system where you'll get these vortices that go back and forth and alternate, and it will naturally mix the tank. It's just how unstable systems will behave. It will never reach a stable equilibrium where you have a stable vortex or eddy that traps the material. It'll keep mixing this way, and it'll keep flipping back and forth. So we end up with these counter current for better mixing. The instabilities of the turbulence enhance the mixing process. But this isn't the only solution that would be inexpensive to do. So let's go ahead and look at the second alternative here. This time we're going to go ahead and move the outlet to be opposite the inlet. That seems like a good idea. And then we're going to put a curtain across the inlet. So right here we're going to put in this curtain. We're going to leave a small gap across the bottom. And then when the jet comes in, it should hit the curtain. It'll diffuse in this area where we should get a fairly high concentration, but then it gradually bleeds out across the entire tank. And we should get better mixing from that as well, because we've broken up that high concentration jet. And we no longer have a jet that's creating vortices that are stable. So let's go ahead and look at that in the model. We'll put the curtain in there, and then we'll turn the flow on. It goes across here. It builds up a little bit here from the jet, but then it bleeds out uniformly underneath that curtain, and we get much better mixing from that, or a more uniform concentration. So that, again, is an alternative to the original design. The CFD model allows us to calculate the coefficient of variance, or how uniform or non-uniform the concentration is of whatever chemical it is that we were adding. We want a low coefficient of variance, so we can look at this, and obviously the best solution is the one here at the end that used the curtain across the bottom. However, what you can also do here is you can game these systems against each other, meaning perhaps the curtain is more expensive to install than what this alternative would be, but now you can see, so I get twice as much mixing for going to a curtain instead of the jets, and you can decide if that's worth it or not, and you can pick the one that's the most economical. So let's go ahead and, the difference between these two is quantified here, because we can get numbers out of it. So the original baseline condition had about 22% waste of the hydrogen peroxide that was just unused and would exit before it was consumed. The best solution ends up consuming 99%. So we cut down on our waste with substantially, we've done a 22% reduction in the chemical dosing that was required, and it's much more efficient. And then maybe the most important thing is the bacteria reduction that's achieved actually improves. So we're using less chemicals, getting better bacteria reduction, so there's a cost savings there and better performance of the system. Okay, let's look at the second case. This one has to do with air that's going to be injected in the bottom of an existing tank. So we have this 60,000 gallon tank. It's being used as an aeration tank. And we want to remove or relocate where the air injectors are to see if we can improve the performance of the system. Now, when we look at the modifications, and this is almost always the case if you're dealing with an existing condition, if it's not a new build, your hands are tied and you're going to be limited to what you can do. But this is where the CFD is helpful, because it lets you explore the different options that you do have available and which ones will perform the best. So the first picture that we see here, this one, this was the existing condition, and there's 3 aerators right here at the top. The jet comes in, exits to the right here, and this is how they went ahead and allocated the aerators. Don't ask me why, that's just how it was. That's the starting point, okay? And we want to improve on that, and so one alternative that was explored was proposal 1. Let's go ahead and bring these 2 up here, and we'll make this more symmetrical. We'll keep one over here, and we'll put one down here. So the flow comes in, and then it goes out to the pump. That might be better. And then, of course, the one that everybody would immediately point to is just make them uniform. Don't be fancy. This should be the baseline condition that you start with, and then improve it if needed. So let's go ahead and we can run those. This is side by side for option 1 and option 2, so the baseline is out of there, but we'll start the clock running and the mixing here. You can see that the dots where the aeration is coming in, and then you can see the one that's uniformly distributed as well. And if you look carefully, and I'll circle it here at the end, you'll notice that the concentration starts to build up in this area here. So there we go. So it's not terribly uniform. Both of them are much better than the initial condition was, but if you look carefully here, you can see that the one on the right performed much better. And I suppose in this case, maybe that's intuitively what all of us would have guessed, but the model goes ahead and shows it. And most importantly, it quantifies it for us. So we can see that we get a 10% increase in the oxygenation over what we had previously. And then the last case that we're going to look at, let me bring up a picture here in a moment. So this is the cracked manifold that was found, and we need to try to understand why that happened before we go fix it. We can just replace it, but then we're going to be replacing it regularly. That's good for the person that replaces it. It's not good for the person that pays. So there it is, it's broken. And this is what the pumping system looks like or can be modeled as. So we have pumps down here at the bottom behind the chairs for you. The flow is coming up. It goes out here and then drops down into a common header where the water flows out. We're going to fail or turn off pump number 1 when the animation starts. So it's going to start with all the pumps running. We're going to turn off this pump. And then what you'll see almost immediately is the flow is going to reverse and fall down here. And what we're interested in is watch this area here for what's going to happen next. Okay, so there we go. Pump number 1 has been turned off. The water's coming down. And then watch the air pocket here that comes up. Now it's water solid. The flow is reversing. We see this air pocket coming up here. It's going to work all the way up until it gets here. It goes up, it burps, and you get a violent pressure transient in that moment. And then the water falls back down. And it is, in fact, that pressure transient that was causing the problem. And once you know that that's what's going on, the solution is very obvious and very easy. All you have to do is break the vacuum here at the top and put in an air valve. But if you don't know that that's what's happening, it's a little bit harder to know what to do. So this is the simulation after the air valve has been put in, just confirmation that it will work. Now you no longer get the burping effect here. There is no more a pressure transient. And all that we had to do was put a vent in the top. It's a very simple fix, but knowing what the fix is, of course, is the real trick. Other areas where this can be used, and I think this is probably my last slide because I'm pretty close to time. So pipeline modeling, pumps, transfer of liquids is a good use of CFD. Mixing efficiency and recirculation, I think we just saw that. Chemistry, so there is some limited chemistry that's included in the model that can be done. Solid settling, we can model particles in the fluid, and that's also physics-based, so you can see where the particles will settle out, where they'll accumulate. So oil, water, sand separators are a very good application because we can model 2 fluids with sand and separate all 3 of those and see whether that's going to perform as expected. And then desalinization and carbon capture also. And so with that, I'll go ahead and stop. I think I'm right close to time, and we'll take questions, I believe, in the discussion later.
Thank you, Dr. Dan, for the presentation. Moving now to the 4th presentation from Mr. Siva Kumar Kota. Mr. Siva Kumar. Mr. Siva Kumar Kota is Head of Technology of Gradient based in Abu Dhabi with extensive expertise in chemical engineering. He holds a master's degree in chemical engineering from the Indian Institute of Technology, Madras, 2005-2007, complemented by a thesis-based master's from Technical University of Berlin, a highly accomplished professional with 7 patents demonstrating a strong commitment to innovation and excellence in technology development. Mr. Siva, the floor is yours. You have 15 minutes. Thank you.
Thank you, Professor. Good morning to all. So I would like to talk about our Alkali is a spin-off from Gradient Company. It's meant for the transforming the brine, particularly produced water, to battery grade lithium and subsequent other minerals. So we feel this is only the sustainable pathway to circular water reuse as well as recovering the minerals. The Alkali is dedicated to accelerating the production of lithium especially, and of course for the battery manufacturing you need other minerals also like copper, nickel, cobalt and magnesium, and we are working on all the minerals recovery from the produced water and geothermal brines and solar brines also. So as a short brief about Gradient, the Alkali, they born from the Gradient labs, So we are a technology company pioneering the differentiated end-to-end solution and provider. And we work on the highest value industrial wastewater segment. Some examples are PFAS, very trending topic in US and Europe, and also on the critical minerals like lithium, cobalt, and nickel. And one of our strong portfolio is semicon industry and food and beverage and mining renewable source also. We are 1,200 employees, and our solutions across more than 90 countries, and we do have more than 2,500 plants across the globe for the water and wastewater treatment. So our main portfolio, I would say that most prolific R&D innovation engine. Last year alone, from the Gradient R&D labs, we launched cure chemicals and fully integrated solutions of PFAS and the alkali, which is we are talking today, lithium and green hydrogen. Just a couple of minutes ago, we presented on the green hydrogen also. So in Oman, in collaboration with NAMA, we started NAMA Innovation Center very close by 10 minutes from here. And we are dedicated to Oman and working on green hydrogen and some of these minerals in our lab also. So other than the Oman, we do have our innovation center in Singapore, Abu Dhabi, and regional application labs across other locations also. And these all labs are, for the industrial, scale bench testings, as well as developing the new innovations. So one of the important technology which we are using in produced water as well as the critical mineral production, what we call it as a gradient grade innovation, which is a CFRO technology. We all know about seawater, which works on the principle by using the osmotic pressure. And we all know about forward osmosis, which uses the principle of concentration gradient. Our CFRO technology utilizes the both key principles. One is the pressure, osmotic driven pressure, as well as the concentration gradient. Using these two synergies combined with that comes with the CFRO. In simple term, it is a OARO, osmotically assisted RO system. If we look at the graph, x-axis is the concentration gradient, and y-axis is the energy consumption. At present in the market, we already know that brackish water and seawater exist. Anything beyond 8% or 10% concentration, we do have a solutions of evaporator and crystallizer. So we all know that evaporator and crystallizers requires larger capex, and opex also will be very high. So that's where our CFRO technology, which is a part of RO Infinity, can bring in the same concentration gradient we can achieve with the lower energy consumption. We feel this is the sustainable solution for the minimum liquid discharge. And it is a very simple solution. Being the membrane-based solution, it can be effectively utilized. So particularly today on the lithium topic, we call it as EC square. EC square is nothing but extract, concentrate, and convert. So this is the world's most efficient solution for accelerating the critical mineral production, especially lithium and other technologies. So if we look at what are the focusing elements, extract is mainly for the lithium. Concentrate we are targeting for the lithium plus other copper and nickel also. And the convert is the place where we are using completely on the lithium carbonate perspective. So why do you need a lithium focus, right? Traditionally, if we look at the lithium market, right, electrical vehicles, the demand is growing, So for 2030, the demand for electrical vehicles, we need batteries. Batteries, key compound is the lithium. If you are looking at the composition wise, out of the battery, 40 to 60% is the lithium. For getting that 40 to 60% lithium, existing sources are hard rock lithiums like mines. So across the globe, mines are concentrated in few locations, China or maybe in Australia and US and some portions. So we need to meet that demand. Demand exists. So to meet that demand, what are the other sources? So you call it as a triangular countries, Chile, Bolivia, Argentina. They do have a salar brines that is, and other than that, if we look at it, is only present in the geothermal brines. Another source where we are discussing today, the first case study is with one of the leading US energy company. So they do have a subsurface brine. variable technologies to recover the nickel and cobalt also. The plant capacities, so that's where produced a good water. The simplified process scheme, what we are showing is, as we all know, simplified process scheme, what we are showing is, as we all know, that chemical or contaminant extraction, followed by our CFRO technology. Finally, once you get the COD will be very high, 15,000. Other than that, if you look at the specifically TDS, 295,000 milligrams per liter, and the barium is 15,000, and strontium is 8,000, particularly this produced water, So we recover the barium and strontium. At the same time, and pH is acidic, 4.5, We need to do the pre-treatment to recover. If you look at the total lithium is 328, Flows are variable, 3,000 to 10,000 or 40,000 barrels per day flows are available. The picture, what you look at, the color picture, the IBC which we received in our lab did the experiments. So, we use definitely online measurement is very important. Let's say lab we can do with ICP and all. We were constantly thinking, if you're deploying this technology for the full-scale plant, what are the ways to do the online measurement? That's where we tried with the different, the instrument like ICP or NMR technologies, and we found that some of these technologies can be deployed online, especially NMR-based technology, to identify what is the lithium levels in the feed as well as the extracted stream and final concentration. In that way, we are completely providing end-to-end solution. So if you look at the results, right? So overall, we could able to recover more than 95% of the lithium, and COD we could able to bring down 99.5%. Why we need to do this one is, lithium carbonate purity is very important. 99.5% is the battery grade lithium. In case if you are not able to meet this battery grade, our product value will completely diminish. An example, maybe right now, a few years ago, per ton of lithium carbonate was $40,000, but today it is $10,000 per ton. If this purity, if you are not meeting, then it may become $5,000, or sometimes it's not a saleable product also. That's very important. So during our experiments, we could able to prove it, and now we own the field. So we are going to install one large-scale plant in US, Pennsylvania, to produce the complete lithium carbonate. And we confidently say our EC square solution can address or solve the lithium extraction problem using a produced water. We can provide you fully integrated end-to-end process, so to meet the battery grade lithium carbonate. And this will definitely make we are utilizing the produced water. Otherwise, it will be again having an environmental effect, right? So using our technology, definitely we will minimize the environmental impact, and also we are focusing on the reducing the operational cost. So thank you very much. Thanks for your time.
Thank you, Siva, for the excellent presentation. Our next speaker is Miss Ibtihal Hassan Al-Bahrani. Miss Ibtihal, to the floor, please. Miss Ibtihal is going to talk about advancing water sustainability through circular economy practices in Oman industrial sector. Miss Ibtihal is a certified chemical engineer and Lean Six Sigma Green Belt with 5 years of experience in projects management, specializing in waste to energy initiatives, currently a PMP candidate. She possesses a proven track record in driving technological innovations and operational efficiency. Her expertise spans project reporting, quality control, and delivering impactful studies with a strong focus on sustainability solutions. Key experiences include conducting feasibility studies on sustainable aviation fuel production and optimizing biodiesel processes in Oman. Thank you. The floor is yours. We have 15 minutes.
Good afternoon. It is a pleasure to be here at Oman Water Week, presenting the sustainable and the innovative water treatment solution. For today's presentation, I'll be talking about AlgaSys, which it is the advancing water treatment technology focusing on the algae. And I will talk about how this technology can support Oman toward the full economic circular model within the country. So as you can see here from the slide or the photo, this is how the system looks like. Usually we build the system into a greenhouse to allow the sunlight access, and that's really helpful to grow the algae. We used to build the system from inside. The main thing inside is the pool that you can see here. And inside the pool, we do have the rotating tube. And that rotating tube rotates with low power consumption to allow the interaction between the wastewater and also the algae. The system mainly is depending on the photosynthesis process. So it is a very simple process. We used to feed the wastewater, even the produced water, but it should contain some organic. We feed the system also with CO2 and the sunlight. At the back end, we get clean water, carbon-rich biomass, and oxygen. And one thing to be highlighted here, that for each type of water, we use to cultivate different type of microalgae species, which it is available within the same water or within the local environment. In this slide, I will talk about how the system contributes to a full circular economic. And as we know, most of the industries within Oman, they do have a CO2 emissions. So these CO2 emissions can be captured and feed to the system for the algae growth. The byproduct, which it is the biomass, it is usually a carbon-rich biomass, which can be utilized for a biofertilizer, bioplastic, or even biofuel production. At the same time, the treated water sometimes need to go through further treatment or polishing. Not a treatment, it is only polishing for the water to be utilized like for irrigation or cooling or processing within the same industry. So this is what we meant by full economic, circular economic model. In X2E right now, we do have a full integrated solution of utilizing the wastewater and use it for treating, for irrigation of certain type of oil crops that can be utilized for biofuel production in Oman, as we have a shortage on the feedstock quantities within the country. At the same time, we are planning to utilize some types of biomass, especially for biofertilizer, to feed the farm as well. I will not take a lot of time in these slides, just to show you how the system has been operating successfully since 2015. And this is the plant on China. It's a Koshna development plant. The system has been able to treat 99% of the pollutant. And also in terms of the electricity consumption, we noticed that it is very low compared to the other systems. Also for the carbon footprint, it is the values between natural to negative as well. But for today's presentation, I would like to focus more into the produced water, as right now we do have an ongoing case study focusing on the produced water, especially the hypersaline produced water. So as we know, most of the oil and gas industries within Oman, they are producing more than 8 million barrels of produced water that is unutilized. We know that there is a certain amount that has been utilized for re-injection, but the bigger quantity, usually it is fed into the evaporated bound and it is unutilized. So by using this technology, we feel that we have a good solution, and we have done an algae investigation in one of the oil and gas industries within Oman, like with one of the operators in the north of Oman, and the water is really hypersaline, and the TDS reached to 180,000 ppm. So during that investigation, we have been able to collect different type of samples from the high contaminated evaporated bound, the low contaminated evaporated bound, and also from the side of the evaporated bound. The surprise was that we found good type of algae that's adapt in the high salinity, the high saline water, and it's really plays a very significant role in treating the water and reducing the salinity. So again, as I mentioned, this is ongoing case study. There is a lot of lab work and experiments that need to be done. And for that, we have designed a photomicro bioreactor in a small scale, like on the lab scale, and we will be feeding the produced water from the same industry into that system. Along that, we will be cultivating the same type of microalgae founded. It will be cultivated and fed into the system. So that's all, and thank you for the opportunity.
Thank you very much, Ms. Ibtihal. We are going to move to the last presentation in Okay, our last but not least speaker is Engineer Mohammed Al-Alawi. Engineer Mohammed Al-Alawi is a sewage network engineer holding mechanical engineering from Technical University, in Dublin, Technical University of Dublin. So his talk is about decentralized water treatment systems. He's gonna speak in Arabic. If anyone needs translation, please sit besides to someone who speaks Arabic. Thank you.
السلام عليكم جميعا. معكم محمد العلوي، مهندس شبكات صرف صحي بهيئة تنظيم الخدمات العامة. إن شاء الله العرض اليوم راح يكون عن مبادرة قامت بها هيئة تنظيم الخدمات العامة بالتعاون مع نما لخدمات المياه. وهذه المبادرة هي مشروع تجريبي لتركيب وحدات المعالجة المنزلية لمياه الصرف الصحي. إيش هي المبادرة؟ نبذة عن المبادرة، كذلك إيش أهداف هي المبادرة، وكذلك وإيش الأوتكمز من هذه المبادرة. إن شاء الله راح نعرفها في هذا البرزنتيشن. قبل لا نبدأ في المشروع أو المشروع التجريبي هذا، راح نعطيكم نبذة مبسطة عن الإطار التنظيمي لقطاع المياه والصرف الصحي في سلطنة عمان. راح نبدأ بالإطار التنظيمي أو الهيكل التنظيمي لقطاع المياه والصرف الصحي. بعدها راح ننتقل للأنشطة الخاضعة للتنظيم، وكذلك مؤشرات رؤية عمان 2040 المتعلقة بالصرف الصحي، بحكم أنه راح نتكلم عن موضوع يخص الصرف الصحي. بعدها راح ننتقل للوضع الراهن لقطاع الصرف الصحي في السلطنة، أو بشكل عام التحديات في قطاع الصرف الصحي، ومن ثم راح ننتقل للمشروع التجريبي. طيب، الإطار التنظيمي لقطاع المياه والصرف الصحي في سلطنة عمان، بمعنى إيش هو الهيكل التنظيمي لقطاع المياه والصرف الصحي في سلطنة عمان حسب المرسوم السلطاني 131 على 2020. المرسوم قال إنه وزارة الثروة الزراعية والثروة السمكية هي راح تكون صانع السياسات، بمعنى هي سن القوانين راح تكون في وزارة الثروة الزراعية والسمكية وموارد المياه. المنظم هيئة تنظيم الخدمات العامة. المنظم وظيفته أنه ينظم تنفيذ هذه السياسات. شركات التشغيل، نماء لخدمات المياه، نماء لخدمات ظفار، شركة المرافق المركزية، وكذلك شركة مجيس للخدمات الصناعية، والمشغلون الآخرون. المشغلون هم اللي راح ينفذوا السياسات اللي تسنها وزارة الثروة الزراعية والسمكية وموارد المياه، ومثل ما قلنا المنظم هو يساعد أو ينظم تنفيذ هذه السياسات عبر اللوائح التنظيمية أو الأدوات التنظيمية الأخرى. الأنشطة الخاضعة للتنظيم. معنى الأنشطة الخاضعة للتنظيم يعني أي مؤسسة أو أي جهة تقوم بأي عمل أو أي نشاط من هذه الأنشطة لابد تحصل على ترخيص من هيئة تنظيم الخدمات العامة. والأنشطة مثل ما هي واضحة أمامكم، عندنا مياه الشرب غير معبأة من إنتاجها ونقل وتوزيع والتزويد. المياه الصرف الصحي عندنا تجميع ونقل مياه الصرف الصحي، وأيضا معالجة مياه الصرف الصحي. المياه المعالجة عندنا نقلها وكذلك التوزيع والتزويد بها، وعندنا اختصاصات والتزامات الشركة العمانية لشراء الطاقة والمياه واستيراد وتصدير المياه والربط الدولي للمياه. مؤشرات رؤية عمان 2040. قطاع المياه والصرف الصحي في السلطنة يخضع لمتابعة من رؤية عمان 2040. هذه بعض المؤشرات. طبعا مجموع ممكن حوالي 10 أو 11 مؤشر، ولكن أنا راح استعرض هنا 3 فقط بحكم أنها متعلقة بالبرزنتيشن أو موضوع اليوم. عندنا المؤشر الأول هو رفع نسبة التغطية بشبكة المياه الحكومية للسلطنة. والمؤشر الثاني هو رفع نسبة التغطية بشبكة الصرف الصحي لمناطق السلطنة. والأخير اللي هو رفع نسبة الاستفادة من المياه المعالجة. مثل ما واضح أمامكم عندنا المحقق باللون المستطيل اللون الأخضر في نهاية 2024، والمستهدف 2040 باللون البنفسجي. عندنا في المياه المحقق على نهاية 2024 73%، وإن شاء الله النية أنه على 2040 راح تكون 96%. طبعا إيش المقصود بنسبة التغطية؟ أي نسبة أو وصول الشبكات لهذه المناطق. نفس الشيء عندنا رفع نسبة التغطية بشبكة الصرف الصحي. عندنا المحقق في نهاية 2024 كان 36%، والتارجت ل 2040 79%. بالنسبة للاستفادة من المياه المعالجة عندنا في المحقق نهاية 2024 49%، والمستهدف 2040 هو 71%. الوضع الراهن لقطاع الصرف الصحي، بمعنى ما هي التحديات في هذا القطاع في الوضع الراهن. مثل ما لاحظتوا نسبة التغطية في الصرف الصحي منخفضة مقارنة بنسبة التغطية بخدمة المياه. نفس الشيء طول فترة إعداد وتنفيذ مشاريع شبكات ومعالجات مياه الصرف الصحي. ثالث شيء عندنا غياب خدمة الصرف الصحي يؤثر بشكل مباشر على البيئة، وهذا واضح. عندنا التحدي الرابع انتشار بعض الأمراض مثل التهاب الكبد الوبائي، وسبب أنه هذه التصريفات تصير في باطن الأرض للمياه الجوفية. خامس شيء عندنا انخفاض العائد والاستثمار في هذه أو هذا قطاع هو الصرف الصحي. ما في أي استثمار أو ما في أي عائد من هذا الاستثمار، والاعتماد كله على الدعم الحكومي. كذلك ما نقدر نجذب الاستثمار الخاص أو الشركات أو التوطين. طيب نجي للمشروع. نبدأ على المشروع. مثل ما ذكرت هي مبادرة من هيئة تنظيم الخدمات العامة بالتعاون والتنسيق مع نماء لخدمات المياه لتركيب وحدات معالجة مياه الصرف الصحي في المناطق أو المخططات ذات الكثافة السكانية المنخفضة، مع الحرص على تحقيق الكفاءة العالية في التكلفة وجودة الخدمة وسرعة التنفيذ، بالإضافة إلى استغلال المياه المعالجة بشكل فعال وآمن. الصور هذه نماذج على وحدات الصرف الصحي. أهداف المشروع. مشروع تجريبي له مواقع وتم الانتهاء في فبراير 2024. إعداد المواصفات ونطاق الانتهاء في فبراير 2024. إعداد المواصفات ونطاق العمل صار أو انتهى في 16 يونيو 2024. الموقع الثاني زغي بولاية صار أو انتهى في 16 يونيو 2024. الموقع الثاني زغي بولاية دبا. الموقع الثاني زغي بولاية دبا محافظة مسندم كذلك. دبا محافظة مسندم كذلك. وعندنا ينكت يوفر له هذه. وعندنا ينكت يوفر له هذه الوحدات. هنا موجودة مثل ما واضح أمامكم، هذه في أحد المدارس تم تركيبها، وهنا نفس الشيء.
Questions and answers. I'm inviting all the speakers to the floor, please. And then I'm inviting all the speakers to the floor, please. And then okay. So any recycling is processed recovery of resources or reuse of resources is about. So a decision maker is not interested only in the technical aspects of recycling, but at the end of the day, whether the technology is going to be adopted or not depends on how much cost saving is going to be happening and how much benefits are going to be flowing to the company, whether it is private company or public company. So this is the whole framework which, I mean, any intervention, any adoption is going to be under this umbrella. Okay, so I'm opening the floor for questions. Yes, please. The micro, please.
I got a question for Dr. Gizler. For the case when that, just wondering how long it takes to simulate or to design that case. Staff, or if it's designed by, let's say, an end user just like us, for instance. And put the properties of your fluid. What are the limitations there when it comes to putting the inputs of the fluid in terms from chemistry point of view?
Now let's try. That's better. Remember to use the on switch. Yeah, two really good questions. Let's start with the second question first. In terms of the properties of the fluids, you can define almost anything that you would like within Flow3D. So if you know the viscosity, you can change that for any fluid that you need, including non-Newtonian fluids. So if you have a mud flow, for example, you can specify that. As long as you know what the properties are, you can specify them in the software. The more difficult part is usually getting those properties. But if you can get them, we can specify them and should be able to get it to behave properly. The second question was, how long do some of these simulations take? That one's a little bit harder to answer maybe, but the example that I showed, the first one with the mixing jets, that probably takes an hour maybe to set up the model, and at that point you just let it run on the computer, and the computer runs by itself. There's no, you don't do anything, and that'll probably run in the order of a few hours to get a good simulation. It depends a little bit on how long that you need it to run for. I think those ran for a full 86,000 seconds, so that would be 24 hours. So those would be a little bit longer, but that influences how long that it'll run. But it's very efficient code.
Micro, please, here.
السلام عليكم. سؤالي للمهندس محمد، يعني ما شاء الله المشروع جميل وفكرة يعني بالنسبة لي جديدة وحلو ان هو يتم coverage لحتت لمناطق نائية، بيبقى صعب فعلا التكلفة. سؤالي، هل هو تم النظر في تكلفة الصيانة بعد كده للوحدات دي؟ لأنه هو الوحدات دي أنا شايف إنها بتتركب تحت الأرض أو بتتركب، التكلفة بعد كده بتبقى كبيرة في موضوع الصيانة لأنك أنت بتعمل treatment. هل تم النظر ده
نعم. مثل ما قلت في البداية، هو مشروع تجريبي، والمشروع التجريبي دائما تراقب فيه الأشياء هذه من ناحية تكلفة كأسيت، من ناحية تكلفة كأوبريشن أند مينتننس. في النهاية أنت بتطلع بقرار على أي أساس؟ راح تقارنه بالمشاريع التقليدية الحالية، هل هو أقل أم أكثر؟ هذا إن شاء الله اللي راح نعرفه من خلال هذه الفترة بعد عملية التشغيل والصيانة إن شاء الله. أو منطقيا هو أقل من ناحية الصيانة إذا قلت يعني، بس إن شاء الله في الواقع لازم تكون عندنا أرقام حقيقية بناء عليها راح يتم تحديد هل فعلا هو أقل أو لا، أو هل يتم اعتباره كخيار بدل المشاريع التقليدية.
أول سؤال، فهد العبري، شركة تنمية نفط عمان. السؤال الأول لمهندس محمد، بالنسبة للفاقد، هل في هناك متابعة للفاقد في شبكات الصرف الصحي الموجودة حاليا؟
إذا بغيت الصدق حاليا يتم متابعة الفاقد في المياه. بالنسبة للفاقد الصرف الصحي هو ما في فاقد، ممكن نقول انفلتريشن قصدك اللي هو يدخل.
لا، هي الفاقد اللي هو يمكن انك اذا عندك تصريف او فاقد في الشبكة نفسها، فهل في هناك يعني مثل ما تقول متابعة
مؤشر قصدك مؤشرات
بحيث انه
حاليا لا يوجد مؤشر لمتابعة فاقد في الصرف الصحي. في مؤشر لمتابعة الفاقد أو تقليل نسبة الفاقد في المياه، بحكم انه ما نتوقع ان يكون في فاقد في شبكات الصرف الصحي كثر ما يكون هو في من السبتك تانك اللي موجودة في المنازل اللي تروح دايركت على التصاريف غير القانونية.
شكرا. عندي بعد سؤال I have another question for ابتهال. For algae production, which you are doing now a lab testing to test the produced water to produce the algae. What is your proposal actually in terms of the value which algae is going to add in terms of the products?
So first of all, our concern was that the TDS is very high in that site. It is up to 180,000 ppm. We know that the algae can grow to 80,000, but from what we have seen on the site, that there is still some type of microalgae presenting on that water, which has the salinity up to 180. It is a good indication for us, but we would like to run those experiments just to confirm that the system will be able to treat the water, and there will be like no harm for the algae to treat that water or to be presented in that water with that much salinity.
What's the value streams of
the species? The biomass? Yeah, so this is part of the R&D scope or the experiment that we will run. So based on the experiment, we will see what type of biomass will be created, whether it can be processed to be utilized as a biofertilizer or biofuels also, or bioplastic. We don't know yet. It's really depending on the characterization, but from the type of algae we found till now, there's two types that can be utilized for biofuels and biofertilizer.
Thank you, Tal. Just to follow up with Fahad question from video. I think we have done similar question with SQU to investigate what type of algae that can stand. And we already identify this one, how this algae who can stand in hypersaline water. So I don't know what the difference your project compare with the project what you are doing now. Because we already done this one with SQU, and I was part of that technical team. So I don't know what's the difference. Are you aware about this study, or with Dr. Alami Al-Haj from, not Dr. Abdo, what his name is? No, I don't remember his name, but he is from SQU, colleague, Dr. Ryan, yes. So what's the difference between your study and that?
Okay, we know about the study that has been done. We don't have a copy of the study, so we couldn't see everything, but we have discussed with, I can't remember the doctor name from the SQU. I think so, but Dr. Lamia, she connected us with him. Yeah. So we had a discussion with him, and we found that the scope is different than our scope.
Yeah, because our scope is to produce biofuel from this.
Yes, so our scope is different. Our scope mainly is to treat the water.
Okay.
Yes.
Thank you. Another question is to مهندس محمد. المقترح مال STB مشان المنازل can treat the water to which level? Is it class A or class B?
هو based on specification standards, either class A or class B.
But that will be difference. You need more process for it to meet class A, what I'm saying.
Yes, I know. So that's why we set specification for the units.
Okay, so your specification based for class A?
Sorry?
Is your specification in your tender is for class A or class B?
Class A.
Class A.
Yeah.
And this will be for per menzil or per house, or per, as communities?
Per house.
Per house.
Yeah.
Each house has got 1 unit.
Yeah.
Okay, thank you.
Okay, thank you. one last question and then over there, please.
Assalamu alaikum. This is Aziz Al Maktoumi, OK Operation Engineer. My question is to Moza. It's really a great achievement to recover oil from water by this way, as I see the sample before and after. So what type of chemical other than oxygen scavenger used to recover the oil from this influent? And the other thing, the time which has been taken to reach to this stage, to the clean water, after injection the chemical, and the quantity of this chemical to be injected, as well to reach to this stage.
Yeah. For the type of chemical, maybe there was a misunderstanding. The type of chemical we are using to recover this oil, we use the demulsifier and de-oiler. And we are injecting this both chemicals very close to inlet of the tank. And the time we saw the improvement, actually because it's been long journey since we got the optimum dose rate for both chemicals. But the trial almost took us almost a month because we have started with with one of them, then we introduced the second one, and then we keep playing on the injection rates just to reach the optimum dose rate required to reach the required oil in water at the outlet side. What other questions you have?
The time will be taken.
The time will be taking as a direct impact. Normally, we saw the impact within 2 to 4 hours. We can see the impact in the outlet water sample. But for the whole journey of trial, it takes from us almost a month or month and a half.
Okay, the follow-up question, the oil content for the influent, how much the maximum you can receive to be treated?
For the inlet?
Yes.
As per the design of the tank, it can handle up to 2,000 ppm at the inlet side, but even we are sending much less than that, and the tank couldn't manage to achieve the outlet specification without chemical.
Thank you.
Okay, thank you very much. I'm going to raise a few questions to the speakers. I'm going to start with John. Can you give a short or a brief description of what you are doing in the site Sayala, and what are the advantages of doing that? What are the benefits? We have 2 minutes to summarize that, please.
Promoter. So within the site, what we're proposing to do is actually the utilization of the algae system. And to do that, what we want to do is make sure that we look at the carbon intensity score of the entire process all the way through from the inception of the water coming out the ground to be processed, the byproducts that come from that to be then processed into energy to cover the energy cost of the actual process system itself, and then the byproducts from that process to be utilized in the agricultural sector to grow our crops. So effectively what it's going to do is a full life cycle or a full closed cycle of all of the byproducts that we have from our processes. So I'll give you a hint of where we're going with this, but it's going to be algae to biogas. And then from that process, we've got biogas, we've got heat, we've got power, which recycles back into our main process lines. The fertilizers that come from the back end of that process then go into crop cycles. So we produce fertilizers to make sure that we can take desert ground and desert areas into fertilized ground. And that's especially interesting for areas like the center of the interior, where infrastructure isn't abundant. There's nothing there. So we have to create everything to be able to do this. So the idea is to take everything offline and have an independent source of everything that we need to create the biochain.
Following this explanation, I have two clarifications. The first one is how this is going to reflect on cost of barrel of oil. Yeah. What is your extra cost per barrel of oil? And then the second question is, when it comes to using this algae as fertilizer, is there a risk in terms of heavy metals? Because this is extremely important when it comes to agriculture. If you are having algae which is contaminated with heavy metals, then you are bringing this to the food chain, and then
Absolutely.
we have serious problems with consumers.
Yeah, absolutely. So 2 points to that. So the cost, effectively what we're trying to do is to take the water for free. So there is no cost base to the operator to treat this. And that's because how we look at these projects within Europe, within North America, a lot of these projects are heavily subsidized. They don't work unless you have subsidies behind that. Within the GCC, you don't have subsidies for these things unless it's hydrocarbon. Hydrocarbon subsidized, but the green side is not. So what we wanted to do is make sure that the byproducts of what we create are recycled into the process to lower OPEX, but increase the byproduct of what we're ultimately creating, which is the agricultural product line, to cover the cost of our generalized OPEX, our levelized cost of CapEx that have to be put into the system, and just take it over a longer cycle. So it's a consistent infrastructure like you have with REMA, like what you have with Bauer Nimmer. It's but a closed loop system, so it's much more effective, much faster. And in terms of heavy metals, to the guys that are working with Gradient, it's exactly the same line. We have a company called Pangea. What Pangea does is it specializes in looking at how do we create specialized fertilizers and composts on site. So we have heavy metal extraction, we have PFAS extraction, and any kind of element that's within there that we can look at to make sure that the organic fraction within the compost or within the fertilizer is within European spec, to make sure that we don't have any influences there. The one part of it, I guess, is that we don't really have to care about that too much because it's an energy crop, so it's not going into the food cycle. But what we don't want to do is build saturated lands. So having saturated amounts of salinity going back into the soil, saturated amounts of heavy metals, boron. We want to make sure that they're extracted so that the soil that we do create in the new areas that we create, these agricultural lands, are as fertile as you could be. So what you're doing there is then you're taking a land that effectively has no value and putting a huge amount of value on there. So then later that land value can accrue to a value within the company.
Thank you. Ms. Musa, now I'm going to ask you a few questions regarding the percentage of water reused or injected in the well fields to enhance the recovery. And then what is the proportion of water that is really not injected and needs to be treated? And then what are the other alternatives? The alternatives is, the existing alternatives are evaporation ponds. But can't you also think about re-injecting this water in deep aquifers that are not water aquifers? So, I mean, what I'm trying to have is the full picture. So you have produced water. Some of it is reused for enhancing oil production. Some of it is going to be treated. How much is that water going to be treated? And what other alternatives, such as evaporation ponds and the re-injection of this water into deep aquifers that are not used for water?
Maybe I missed to add that point. The end user of this water, treated water, actually it goes to 3 streams. One of the streams is re-injection, as I have mentioned before. One stream is going for deep water disposal, and the third stream is going for irrigating these kind of crops in an open ponds there. And at the final stage, after irrigating these crops, it will be reaching to a final area like evaporation pond. We have also big quantities of salts remaining there, which has also a plan in the future to be utilized somewhere.
And in terms of cost, which alternative you think it's the most economical? Because what we are observing these last days is a sharp fall on oil prices. And every addition to the cost of extraction of oil is going to be really challenging. So we are talking about $64 today, a fall of $10 in a couple of days. Expectations are talking about $55 to $40 per barrel, and then you are talking about technologies that are going to increase the cost of extraction and the cost of operation. So how do you see this?
The 30% which is going for the reed beds, which used to be disposed deeply, as you said, and it was of a high energy intensive. That's why we went for reed beds. In all means, you have to treat the whatever comes from the field, because majority of it will be used for water injection or water flooding. And in case you don't treat it, you're gonna plug those water injection wells and cause defilement to the system in terms of oil production. I hope I answered.
Yes, thank you for the clarification.
For the fluctuation in oil prices, we do take into account for any coming projects the fluctuation. So there is the base case, which is like pricing the oil at $60 per barrel. We have as well cases where we look into the, in case it falls to $30, what will be the case of the project economics? So we look at those scenarios as well. And it depends on the situation really, then we take the decision.
My point is if the oil prices keep going down, can you continue doing these treatments? That's the question.
So we've been operating more than 40 years now. It's been fluctuating, and we had even the oil price going to $20, but we never had to shut down, alhamdulillah. We have done a lot of optimization and cost reduction in terms of OPEX, in terms of the CAPEX, and also reducing, the unnecessary spend of money in terms of the OPEX and other like chemical optimization and chemical injection and other systems.
Thank you for the clarifications. My last question is to Engineer Mohammed Al-Alawi. And then you are talking about a wastewater treatment system at household level. Would it be more economical to look into gray water treatment and then talking about dry toilets, for instance? So, because we are talking today about countries where we have a huge scarcity of water and limited water. We are talking about dry toilets. So why not look into such an option? Because dry toilet, first of all, is going to reduce the volume of water used in the toilet, and then we concentrate on treating the gray water, which is much more cheaper than treating black water.
هذا question مرة expert مالي يعني. أنا مش expert، أنت ممكن دكتور بثينة هنا تجاوبك. طيب نعطي المايك. المعذرة يعني بس question مالك ما شاء الله يعني.
شكرا محمد. As Mohammed maybe said, it is a pilot study, this project. So we would like to see as well, apart from this study, is the economic visibility of installing on-site wastewater treatment. But absolutely, I agree with you. If we recycle or retreat the gray water, it's much better in economics-wise than treated the overall black water. Yes. Scientifically, it is proven. It is more visible and more economic. However, it's very difficult because the area it's already, the area selected For the pilot testing, it's already infrastructure is built, all the houses, it is there, so we don't have that separation system of the gray and black water. We can implement this idea in the new sustainable cities. It will be perfect and more sustainable.
Thank you. Since you have the micro, I'm going to ask you another question because it's very important to look into this decentralized treatment of water. As we know, the cost of treatment of wastewater in a city, big part of it is pumping the water to the treatment station. So by doing decentralized systems and actually at the household level, we are saving a lot on water pumping and water pipes. Can you give us a picture of what is the saving by having this decentralized system compared to the traditional system in percentage-wise?
Yeah. As amount,
in numbers?
Yeah, in numbers, I don't have it. But maybe I will give you like a feedback or historical about these initiatives. So in 2018, we proven the decentralized approach within the wastewater sector, especially because we need to increase the coverage. Up to now, we cover almost more than 75% in the water sector, but it is only 20% in the wastewater sector. So it's come up with a decentralized approach. We need to implement those on site, especially in a very difficult geographical places when it is very difficult or very expensive to build the network and the wastewater, the centralized wastewater treatment plant. And as well as you know, there will be as well the challenge of the utilization of the treated effluents. So the approach it came from here. We have to implement the decentralized, and we can utilize it as well in the same clustered, in the rural clustered area. In figures, I don't have it.
Okay.
So, yeah.
All right, just one last
but
comment
maybe
on
from this pilot, the first pilot project, we can update our master plan based on it.
Sure. One last comment from Mr. Mohammed. Have you thought about the reuse of the water you are going to treat? Because often when we treat wastewater, we don't think about what we do with the water. So now you are doing it at household, and you have the technology to treat. So what's next? So if you are a household and you are treating that water, what are you going to do with this water? Have you planned for that? And have you designed the system in a way that this water is going to be really reutilized?
Yeah, so when we done the tenders, we asked the vendors to provide a solution for the tea reuse. Some of them gave us the use to be in-house. So people in their house, they can use it within their, let's say, some plants or gardens. Or they can use it for the green areas in the area itself. And this done by the vendor itself.
Just, Doctor, I have just to cap with Mohammed words. Now, the things regulation officer, they are working along with Environment Authority to have different category. It's not only A or B, it's based on the use. We have seen it also used in our neighborhood, in UAE. They have different category of classification of the TE based on the use. For example, we don't need to go all class A, whereas we will not use it, we'll use only for landscaping, not for irrigation or not something for crop. Also, it's not going for industrial use because also we are using some of treated effluent in the cooling tower. So that will be based on, I'm just coming with Mohammed, I'm from Nama, and this is something to add up. They are coming with the new standard based on the use.
Okay, thank you for the clarifications. My last question is to Dr. Gessler. Actually, it's not a question, but it's what would be your recommendation to these young researchers who are coming up with new technologies, new proposals in terms of scaling up, and what's the next step they should be doing to make it scalable and how they can do that? So we have seen presentations today talking about new approaches or new examples of treatment. but at lab level, at micro level. And then you have been talking about computational fluid dynamics, which would be very helpful before to do a scaled up system. It's better to do the simulations in order to come up with a scalable system that is operational and optimized. So what would be your recommendation for these experiences that are being carried?
It's a good question. So there's usually when we get to scale up, there's two parts where the CFD engineer or the fluids person has to work with the design team that knows what you can build at that site and what the shapes are that are available and what the geometry is that you might be able to build and what the costs are going to be. And then you model it to see how that needs to be adapted. And then it's kind of a back and forth for construction cost versus performance. So that's that. I don't know if that answers the question or not, but there's definitely an iterative process. And the other thing I do want to point out quickly while I have the microphone, I want to recognize Dr. Amr there, because I'm from the U.S., and so I'm a little bit harder to reach if you have questions, but he's our local representative and works with me and supports Flow 3D. So if you have questions here locally, he's a great resource to reach out to.
Okay. Thank you very much. That really clarifies my point, my question. If no more questions, I'm going to close the session here. So I would appreciate that you again, thank the different speakers for what they have been presenting during this session today. Thank you very much.
Thank you, everyone. Thank you, speakers, for all your great presentations. What? Sorry. Okay, now, thank you all, we will be distributing certificates of appreciation. And we will be starting with John Linden. John he left? Yeah. Okay. So next, موزة الرقيشي. Dr. Dan Gisler. ابتهال حسن البحراني. محمد العلوي. And thanking you, Dr. Selim, for chairing this session. And here is a token of appreciation for you. All speakers, please come to the stage for a group photo. Thank you all.
Sure.
Thank you all, ladies and gentlemen. As we come to the end of this remarkable edition of Oman Water Week, I want to take a moment to express our deepest gratitude. What an incredible journey it has been over the past few days, filled with insight, innovation, and inspiration. This year, Oman Water Week brought together 4,000 participants from 70 countries, including 145 distinguished speakers and 750 engaged delegates. We also welcomed more than 2,600 visitors and featured innovative solutions from over 60 countries in our vibrant exhibition space. These figures are more than just numbers. They reflect a powerful collective commitment to advancing a more sustainable and resilient water future. In addition to the exhibition, this year's event featured a strategic program, a municipal program, a produced industrial program, and a dedicated hydrogen workshop, each offering a focused platform for collaboration, learning, and innovation across key sectors of the water ecosystem. To our sponsors, exhibitors, speakers, delegates, and guests, thank you. You've made this the biggest, most successful Oman Water Week yet. Your contributions, conversations, and collaborations have sparked real momentum toward meaningful change in the water sector. As we close, let's carry forward this energy, the partnerships we've formed, and the ideas we've shared. Now, we invite you to watch our closing video, a tribute to your efforts and incredible moments that made this week so special.
يسرنا بداية أن ندعو الفاضل قيس بن سعود الزكواني الرئيس التنفيذي لنماء لخدمات المياه لتقديم كلمة ترحيبية في بداية حفلنا.
Thank you again. Thank you all. We're grateful for your energy and look forward to seeing you again next year. In few moments, we will be there will be a signing ceremony for first carbon capture application at Sohar Industrial Port area between Sohar Operation Services and Sohar Energy and Investment. That will be in few moments. Thank you.
At the end of the day, I would like to thank everyone for being here with us for the Oman Water Week. It was a busy week. As of now, we will be preparing the stage for signing agreement. Meanwhile, please feel free to stay with us. If you would like to grab something from outside as well, please feel free. The lunch is served. Shukran.
माइक से दे दो
Assalamu alaikum. Excuse me, everyone. As of now, we'll be proceeding for the signing agreement. If I may invite Al-Muhandis Abdullah Al-Saadi, the General Manager of Sohar Operational Services, to the stage. Bashmuhandis Abdullah, تفضل.
Good afternoon, distinguished guests, colleagues, and partners. It is an honor to welcome you to this landmark occasion as we formalize an agreement that represents a transformative for Sohar Industrial Port. Today's signing ceremony marks a launch of the first carbon capture application at Sohar Industrial Port area, a project that embodies innovation, sustainability, and industrial collaboration. Under this agreement, Sohar Energy Investment LLC, as SME entity, will implement advanced carbon capture technology to utilize CO2 bioproducts. The capture of the carbon dioxide will be supplied as a food-grade carbon dioxide to Sohar Operation Services LLC for enhancing the post-treatment operation for Sohar 4 IWB desalination plants owned by Mia Gulf. Sohar Industrial Port, as the landlord, plays a vital role in enabling these initiatives and fostering sustainable industrial practices. Together, these efforts reflect our shared commitment to the environment, stewardship, and align with Oman Net Zero 2050 vision. I extend my sincere gratitude to all stakeholders, Sohar Industrial Port, Mia Gulf, Sohar Operation Service LLC, and Sohar Energy and Investment LLC for their collaboration and dedication in bringing this visionary project to life. Now, I invite representatives from Sohar Industrial Port, Mia Gulf, Sohar Operation Service, and Sohar Energy and Investment to join on the stage as we commence the signing ceremony. Let us celebrate this milestone and our collaborative commitment to greener future.
Assalamu alaikum wa rahmatullah. I would like to congratulate all of us for this project. It's, as I said, it's a CO2 capturing, one of the first one in Sohar industrial areas. And it's a partnership between a private sector who initiated this in order to secure CO2 for the water production. It's a water, as Mr. Abdullah has indicated, it's a food grade CO2 that will be introduced into the water as part of the treatment. And this is, as I said, a partnership between both private and non-private, initiated actually by the private sector, and in order also to help and support the SMEs, initiated again by the private sector. Again, I wanted to thank everybody for this work. It took some time, and it's also to secure long-term longevity of water supplies for Oman. Wassalamu alaikum wa rahmatullahi wa barakatuh.
I would say a few words as well on behalf of our company, Sohar and Energy Investment. This project actually, it's aimed to extract the CO2 from the emissions in Sohar Industrial Port area. We selected Sohar Industrial Port area because there is a lot of emissions there, and we try to control the carbon emission. Plus, with the support of SIPC and good infrastructure in Sohar Port, encourage us as an SME to think about and be creative in introducing some environmental instrument that control the emissions, and it is actually in accordance with the 2040 vision as well, and to reach to zero, hopefully, let's say to reduce the emissions in SIPC area. Thank you very much for your attention, and we also thank again SIPC for their continuous support as SME to come up with a solution, creative solution, and implement it towards protecting the environment. We're proud, and we really thank SIPC again and again for supporting us, and for the client to trust the Omani company that they can come up with solutions and creative methods towards achieving the better environment for everyone. Thank you very much. Thank you.